Crossing the event horizon, a journey into a black hole. At the edge of a black hole, something strange happens. Time slows, space bends, and the universe you came from begins to disappear. Not in a flash, but in silence. This boundary is called the event horizon. Once you cross it, there is no return. But what does that actually mean? What would you see? And what does modern physics say happens beyond this point of no return? This is a journey into one of the most extreme frontiers of reality. What is a black hole? A black hole is not an object in the traditional sense. It is a region of space where gravity has become so intense that nothing, not even light, can escape. Black holes form when massive stars collapse under their own gravity, compressing enormous amounts of mass into an incredibly small volume. The result is a distortion of space-time itself. At the center lies what we call the singularity, a point where density becomes infinite and our current understanding of physics breaks down. But long before reaching that center, you encounter something else, a boundary, the event horizon. The event horizon is not a physical surface. There is no wall, no shell, no glowing edge. It is simply the distance from the black hole at which the escape velocity exceeds the speed of light. Beyond this point, all possible paths through space-time lead inward. Even light, moving at the maximum speed allowed by the universe, cannot escape. From a distance, the event horizon appears as a perfect black circle, light falling in, never to return. But up close, the experience is very different. Approaching the black hole. As you fall toward the black hole, the universe begins to change. Stars behind you warp and stretch into glowing arcs. Light bends around the black hole, wrapping the universe into a distorted ring. This effect is called gravitational lensing, and it reveals how strongly space-time itself is curved. Time also begins to behave strangely. To an outside observer, your motion slows. Your clock ticks more slowly compared to theirs. This is gravitational time dilation, predicted by Einstein's theory of general relativity. But from your perspective, everything feels normal. Your clock ticks at the same pace it always has. You are falling, calmly, silently, toward the event horizon. The illusion of the point of no return. From far away, something strange appears to happen. As you approach the event horizon, you seem to slow down. Your image fades, your light becomes redder and weaker. To the outside universe, you never quite cross the horizon at all. You freeze in time, but this is only an illusion. From your perspective, there is no dramatic moment, no alarm, no sudden darkness. You simply pass a distance in space and cross the event horizon. Crossing the event horizon. At the exact moment you cross the event horizon, nothing special appears to happen. No shockwave, no sudden force, no visible boundary. And that's the most unsettling part. The laws of physics have changed, but you cannot detect it locally. What has changed is your future. Inside the event horizon, all possible paths through space-time point inward. The singularity is no longer a place you might reach. It is a place you will reach. Inside the event horizon. Beyond the horizon, space and time behave in ways that defy intuition. In normal space, you can choose to move forward, backward, or remain still. Inside a black hole, that freedom disappears. The direction toward the singularity becomes as unavoidable as the passage of time itself. Just as you cannot stop tomorrow from arriving, you cannot stop yourself from moving deeper inward. Here, space and time exchange roles. The singularity is not ahead of you in space. It is ahead of you in time. What you can still see. Even inside the black hole, you can still look outward, briefly. Light from the universe behind you continues to arrive, compressed into a shrinking, glowing region. But no signal you send can ever escape. Your future is now completely disconnected from the outside universe. You have crossed a causal boundary, a limit on cause and effect. This is what the event horizon truly represents. The limits of physics. As you continue inward, gravity grows stronger. Space-time becomes increasingly distorted, and eventually, our equations stop making sense. General relativity predicts that all matter collapses into the singularity, a point of infinite density and zero volume. But infinities in physics usually signal a deeper problem. They tell us that a theory has reached the edge of its validity. We believe that a more complete theory, one that unites gravity with quantum mechanics, is required to describe what truly happens here. But that theory does not yet exist. The information paradox. One of the deepest mysteries of black holes is the information paradox. In quantum physics, information cannot be destroyed, but black holes seem to erase information completely. When matter falls in, its details appear to be lost forever. This contradiction has puzzled physicists for decades. Some theories suggest information is encoded on the event horizon itself. Others propose subtle radiation leaking information back into the universe, and some ideas suggest space-time itself must be rethought entirely. The event horizon may not just be a boundary in space, but a boundary in understanding. The frontier. Black holes sit at the intersection of gravity, quantum mechanics, and space-time. They are not just cosmic objects. They are experiments conducted by the universe itself. Experiments we can observe, but never fully enter. Every black hole marks a place where our knowledge ends, and where future physics must begin. Closing thought. Crossing the event horizon is not about destruction. It is about separation. A boundary where the universe beyond can no longer influence your fate, and where you can no longer influence it in return. A black hole is not simply a void in space. It is a reminder that reality has limits, and that some frontiers can only be approached, never crossed. If you want more research-driven visual explorations like this, subscribe to Frontiers of Vision.